3, lesson 2, we're going to be working with systems still. This time we're going to work with a linear and a quadratic, so a line and a parabola. What we need to remember about a system is that it's two or more functions on the same graph. When we say that we have a solution, it is the point or points, sometimes it's more than one, point or points, oh sorry, there's already an S there, that both functions have in common. Okay, and we'll talk about that in just a second, but it is a point or points, and you're going to see both the parabola and the line hit that same point at the same time. You will see them intersect. Okay, you can put that word here if you want. You're looking for intersection. Okay. Now notice that the first few that we're going to solve, we're going to do that by graphing, and we've got a graphing calculator. Before you can use your calculator, all equations have to be equal to 0. So when I look at my very number 1, that is not equal to 0, and this is the other equation, it is equal to 0. So we're going to put both of these in our calculator, but this one's not ready. Now when I look at these two, I have to determine which one is the quadratic, which makes a parabola, okay? And if it's squared, that means it's quadratic or parabola. So this is my quadratic, this is my linear. That makes a line, okay? Now to get that first one ready for the calculator, we should remove the 3x by subtracting. That is a subtraction sign, it just didn't show up well. So now I have y equals, so that means I'm ready for the calculator. These are not like terms. This is linear, algebra 1, so you should know they should stay separate. Okay. So I'm going to take these two and put them in the calculator because they're both ready. Now you have a decision to make when you do that. You've got a decimal and you've got a fraction. So we need either both to be fractions or both to be decimals. And that's so that when we read our table of information, they match. So I'm going to determine that I'm going to leave negative 3x plus 4.5 as a decimal. The reason I'm going to do that is because I know 1/2 as a decimal would be 0.5. X, make sure you hit minus 3 and squared. Okay. Now, that almost matched, but I got 0.5 instead of 1/2, but that is the same thing. And I'm going to hit graph. So I'm solving this by graphing. So I'm going to look at the picture. The blue is my linear function, the red is my quadratic, and I can tell that they intersect over here to the left. It's kind of hard to tell if it's once or twice. I definitely know at 0 it looks like they're showing something. So here's how you determine that. You go to the table, so second graph, and we set around 0. Look at 0. They have the exact same y value. So when x is 0, both the linear in blue and the quadratic in red have the same y value. So that is a point of intersection, which means it's one of the solutions. So I need to write down this 0, 4.5. Okay? And then I look and I see at 1, the y values do not match. At -1, they don't match. And I just kind of keep scrolling up and I see nothing matching. If I come down, I don't see anything matching. Okay. So when I go back to the graph, I say, hey, 0, 4.5. Yep, that's going to be the only place that they intersect. So they share one point in common. This is it. Okay. Now you're going to want to take out what you had in your calculator because you're going to have two new functions. This function is not ready for the calculator. So I'm going to subtract 3x, same step. So I've got y equals negative 3x. You can put plus 0. You don't have to. It's up to you. You notice that this one is also not set for y equals, so I need to add 6. Again, these are not like terms, so that is negative 3x squared plus 6. Do not write them together. Over here I've got y equals, so that means now I'm ready to punch these two functions into the calculator. So negative 3x, first one. Second one is negative 3x squared. Because that's squared, forgot to label this, but that is your quadratic, and that is your linear. Quadratic has squared, linears do not. Negative 3x squared plus 6. Okay. So we're going to go ahead and hit graph and see if we can tell how many times that they're going to run into each other or intersect. Now I can clearly see that it happens twice. One in the negative 1 or 2 area, and one of them's over in the positive x. Probably looks like x is 2, but we're going to go to the table and figure that out. But I know I'm looking for 2 of them. So at negative 3, they don't match. At negative 2, now this is not matching. 6 and negative 6 are not the same thing. Owing somebody $6, negative 6, and having $6, positive 6, not the same. However, right here at negative 1, you see that the two y values match. Okay, so my answer is negative 1, 3. That is an ordered pair that they share in common. They do not share 0, 0. But if you remember on the graph, I said there were 2 places, so look at 1. Again, those 2 are not identical. They're twins, but they're not identical twins. Here is my other solution. At 2, y is the same. Okay? When x is 2, both functions have a y value at negative 6. So for sure, if you look back at the graph, to the right 2, down 6, that's my first point of intersection. To the left 1, up 3, that is my second point of intersection. So this pair has 2 points where they intersect. This one only had 1. Okay. Next problem. Notice that we are not in y equals. We need to subtract this 1 to get y alone. But where do I subtract 1 on that problem? This is really important. It doesn't go with 1/2 because 1/2 is multiplying by a parenthesis, so you're just going to keep 1/2. You can't touch a parenthesis, so it can't go with that. So it just sits behind. It's your D, A, C, D, okay, from transformation. So that is where you put that number. It goes behind what's already there. Okay, for this one, I need to subtract x. Oh, and this one was squared, so that's my quadratic. This is my linear. Okay, so I have negative y equals negative x plus 6. And I've got one more step to go because there's a negative 1, so I'm dividing it out. So I really have y equals x, negative negative is a positive when I divide. 6 divided by negative 1 is negative 6. So if you want to, you can kind of highlight or circle those so you know what you're typing into your calculator. Ooh, cut off the 1/2. All right, now you have a fraction here, and you don't have any fractions or decimals, so it doesn't matter what you use here. First, we got to clear out what we had in. So I'm going to put the fraction in this time because honestly, you could put 0.5. Does not matter. Squared. Make sure you hit -3 and -1. Okay, that's my quadratic. My linear is x minus 6. Make sure you use minus and not negative. So let's look at the picture. You've got your quadratic, slowly. And your linear. Do you see that this line is not touching the parabola? And the line is headed over here to the right. Parabola is headed up. So these two don't have any points in common. So what we would say is no solution. Okay, they have 0 points in common. All right, we've got this one already in y equals. And when I say this one, this is my quadratic because I have the square. So this has to be my linear. Now notice that y is not alone here. That negative 2 is multiplied by y, so I need to divide it out to everyone. All right, so we get y equals, negative negative is a positive. And 13 divided by negative 2 would be negative 6.5. Now I just mixed decimals and fractions, and we're going to have to change all of this. Okay, so to do that, negative 13 divided by 2 can stay negative 13 divided by 2. The reason I'm going to do that is we've got a fraction, so I'm going to lean towards the fractions this time. okay? So clear that out, clear that out. I'm going to keep the fraction. Oops, I'm sorry, I'm in the wrong place. Here we go. All right, I'm going to keep the fraction 1/4. I'm going to do parenthesis x minus 3 squared. And that's it. Okay, that's my quadratic. Here, I'm going to type in 3 divided by 2x minus, remember, this was 13 over 2. So I'm going to, oops, backspace. I'm going to keep that as 13 divided by 2. Because then my fractions are all consistent. And I'm going to hit graph. Remember, I'm looking for the point or points that they share in common. And there's my parabola. Wow, that's a fat one. Okay, and here comes my line. And it will touch the parabola. It looks like it crawls along for a while, but it probably is going to touch once. But notice I'm at 1, 2, 3, 4, somewhere around 6, 7, 8. So that's where I'm looking in my table for x. Notice that we're not matching anywhere down here. 2 doesn't, 3 doesn't, 4, oh, 5 does. So one of my points is 5, 1. Okay, I need to check others just to be sure. 6 does not. Those are fractions that don't match. Hey, 7 does. So my other solution is 7, 4. Okay? So that is how we work these when we're using the calculator and we're graphing. Notice the question right here at the bottom says, how many solutions can a linear or quadratic have? No solution, that would be 0. We had 1 solution. Here we had 2, here we had 2. So those are our options. They can not touch at all, they can touch each other once, or they can run into each other twice. All right, so now we need to work on substitution. With substitution, why would we need to use it? Sometimes your answers are so large where they intersect each other, you're not going to find it quickly in the calculator. So for substitution, we still want to make sure all of our equations are equal to y, and it's going to make it easier. Now, they put f of x, which is still y, so we're equal to y. This one's equal to y. I do want to determine this is my quadratic, and this is my linear. Okay, quadratic is squared. So when they are both equal to y, these two are both y, then I can set this in y's place. So in other words, 3x minus 1 equals y. This is y. So I'm going to say 3x plus 1 is equal to x squared plus 4x minus 1. I can set them equal to each other when they both equal y. That's very nice. Okay. Now when you have a quadratic, you need to equal 0 so that you can solve it. In other words, factor, hopefully. Factoring's quick. So I want 0 over here. So I'm going to subtract 3x, and I'm going to subtract 1. That's going to be 0, that's going to be 0. Okay, so I'm going to line those two up over here, so negative 3x, negative 1. So I'm clearing out this side. I'm going to get 0 equals x squared plus x. Somebody owes you $1, then they borrow another $1, so now they owe you $2. Okay. Now, once we're set equal to 0, we're ready to solve, so we can factor. We've been factoring a lot this year. It's never going away. The only thing that multiplies to be 2 is 2 times 1. It's a prime number. Now, 2 times 1 will work because if you subtract them, you get a 1. So let's put a 2 and a 1. I need opposite signs, and the sign of the sum goes to the bigger number. So my x-intercepts will be negative 2, positive 1. How does that help me? It helps me like this. When I go to my calculator, I'm going to plug in. This one's equal to y. Okay, this one is equal to y. That's f of x. So x squared plus 4x minus 1. And I'm going to graph. I should see them run into each other twice. I've got 2 different x values. 1, 2. Yep. Okay. So I'm going to go to the table. I'm looking when x is -2. It tells me where to look. You see, that's one of my points. You say, why can't I just use the calculator? I'm going to show you in a minute. I'm showing you with one where you could have. -2, -5, that's one solution. The other one should be when x is 1. Yep, 1, 4. Okay, so how come I couldn't just use my calculator? Because in a second you're going to see answers that are so large you wouldn't have found it ever if you had scrolled through. Okay, so we are going to look at the second one. Whoop, sorry, throwing my pen. Okay. No square, so that's got to be linear. Square, so that's my quadratic. Now remember, I need them equal to 0. I'm sorry, I need them equal to y. This one is not, this one is. So I would subtract 12 x. It's missing an x, so fix that in your notes. I will go in and fix that. So we're going to have y equals -12x plus 36. Okay, we need to have an x on that 12. Sorry, that's a typo on my part. Okay, once I do that, and they're both equal to y, then I'm going to set them equal to each other. So x squared minus 11x minus 36 equals -12x plus 36. Over here, the linear was on the left, quadratic on the right. Over here, quadratic's on the left, and linear's on the right. It doesn't matter. What does matter is that wherever the quadratic is, I keep it where it is. Don't move it. So that means -12x is going to be added. 36 is going to be subtracted. Again, I added 12x, and I subtracted 36. 0, 0. So I do have it equal to 0. It doesn't matter if 0 is on the left or on the right. Okay? It doesn't matter. X squared. 12 minus 11 would be 1x. Now, -36 minus 36 is -72. Use a calculator and do that correctly. So I'm ready for x and x. Now I need an opposite, so positive, negative, and I need pretty big, 72, but I need them to have a difference of 1. So I need two numbers that are super close together. 72 divided by 9. 9 times 8 is 72, and they have a difference. 9 minus 8 would be 1. So I like that. Again, we said 9 and 8 because I just started at 9. I know 10 doesn't work. Bigger number gets this sign, so positive 9, negative 8. So I've got x equals -9 and x equals positive 8. So we're going to go to our calculator. Y equals, we're going to type in our equation, -12x plus 36. We've got x squared minus 11x. Oops, I hit the wrong thing. Okay, hold on. There we go. Minus 11x minus 36. Okay. Now we're going to hit graph and see if they run into each other twice because we see two separate answers. Do you see how you can't tell on the screen if that happens? And you wouldn't even begin to know where to look. But because I did the math, I can go to the table and look at -9. At -9, do you see that they do match at 144? Wow. That's 1 point. The other one's supposed to be at +8, so I'm going to scroll down there. Do you see at 8, it's -60. So we might not have ever seen, well, we wouldn't see that on the graph that we currently have. So we wouldn't know what to do. But if we solve it algebraically with substitution, then I know exactly where to go look in the table and I don't have to be scrolling forever. Okay, so there's one more to practice and then you'll have some work. Okay, when I look at these two, I see that this one does not have, oh, I just wrote the wrong thing. It does not have the square, so it's not the quadratic, is what I was about to say. Don't write and talk. It's the linear. Here's my square, so this is my quadratic. Okay. Now, my quadratic's ready for the calculator, and my linear is not. So I'm going to add 30 to both sides. So I've got y equals 12x was already there, and we brought over the 30 by adding. Okay. Now I'm going to set them equal to each other. Again, it does not matter. So I'll put 12x plus 30 on the left. It doesn't matter who goes on which side. X squared plus 11x minus 12. Okay. It does not matter. And I want it to equal 0. Leave x squared so it stays positive. So we're going to subtract 12 and subtract 30. We're going to subtract 12x and subtract 30. So what I wanted is 0. I got it. We've got x squared. That's negative x this time, 11 minus 12. And this should be negative 42. Okay. So my job is to factor, and if you're great at factoring, this is very simple. If factoring is still a struggle, this is going to be a struggle. Negative, so I need plus and minus. I need two numbers that multiply to be 42. You could start with 2. You're going to see that 21 minus 2 is not 1. So you can work on 3. 14 and 3 isn't 1. So I'm going to jump up to 6. 6 and 7 is 42, but notice they're separated by one number. So that's what I want. I want 6 and 7. Sign of the sum goes to the bigger number. Okay. So my solutions are for x, negative 6 and positive 7. So I'm going to use this calculator. I got 12x plus 30. My second one, I've got x squared. Oops, nope. I got x squared plus 11x minus 12. And we're going to graph it. And we should have a negative 6 something and a positive 7 something. Now again, do you see you cannot tell where they intersect on the graph? This is why this helps me. When I go to the table, I know to go look at negative 6. You see they match at negative 42. And then I know to go to 7. Oh my gosh, 114. There is no way I'll ever see that on the graph. I have no idea if they intersect once or twice or not at all, because I can't even tell. I just see tiny parts of it. So doing the algebraic part helps me know where I am.